I think we're here, man. We're here.
I think we're here. We're here.
Yeah.
Yes, sir. We're
What's up?
here. We're back again.
How you doing?
No, I'm doing pretty good.
Wait,
I'm
I think the music
excited.
might be too loud. Give me a second.
Yeah, yeah. Nah, but I'm excited. I'm here to for another stream. We had to move the date because Thanksgiving is coming here on and Wednesday. I'm not gonna be able to stream and stuff,
Yeah, yeah.
right? But hey, we're here, for this stream. We're gonna do a little bit of dynamic programming. We're excited, you know, late
Emphasis on a little
nights
bit.
a little bit, yeah, a little bit, cause
Emphasis.
cause we're Carlos has had a long day. Just came out of school, so we're gonna keep it short, but right, but still be here
Our
committed
goal,
to
honestly,
trying.
our goal is to solve this house driver problem. If we could solve it,
Yeah,
that's a medium. If we could solve
yeah,
it,
it's a medium.
I'm happy. I'll go to
Yeah,
sleep happy tonight.
each but
Yeah. If we don't
hopefully
solve it, I'm not going to sleep happy.
you're
And
not
that
going to
means
sleep happy.
I'm not waking up happy.
Oh no, but
Yeah.
oh no.
So
No, but hey, we're gonna give it a
pressure's
shot.
on.
We'll see. We'll see. We'll see. We'll see how it goes.
Okay.
But yeah, so I'm excited, a little bit of a short stream today, but hey, we're still here committed, delivering lead code
Well,
problems,
you never know,
streaming.
man. We're saying short stream, but you never know.
That is true.
We
That is
might
true.
get into it a little bit,
Yeah,
and
that
try
is
to
true.
figure it
So
out. So
all
at
right, fair
minimum
enough,
an
fair enough.
hour. At minimum an hour.
Minimum an
That's what
hour.
we planned. But wherever
We'll
the
see.
problem takes us. But
Yes,
before we
yes.
start, how was your week, man? How was your
My
weekend?
weekend, oh, it's
Weekend.
been this weekend has a little bit been a little hectic. Got a Friday. I went to the movies. I went to watch what's it called? Gladiator 2. It's
Gladiator.
an alright movie. It's an alright movie. I heard a lot of people say that Gladiator 1 was better, like way better. So, you know, but it depends, on the mood you're in to watch it. And then on Saturday, went to a baby shower. That
Baby
was
shower.
fun. Yeah. Then on Sunday, went out to get some wings and stuff. So it was
What kind
good.
of wings? What kind of wings?
Wingstop. I got lemon pepper and parmesan. Ooh, And bro, and then the Wingstop, they sell like the little cheese, bro. You dip the cheese, the wing in the cheese,
All right, see, look.
dip it in the ranch, and
Look, you
shoot.
know what I'm talking about? Like you had me at the lemon pepper, oh cheese, yeah, for the fries. You said cheese for the wings.
Yeah, you dip it, bro. You drench that thing,
No,
and you go. Whoosh, whoosh, it comes out
no,
yellow.
no, no. I do not
Bro,
agree with that.
you're missing out, brother. You're missing out.
I mean,
It's amazing,
I like the cheese, but not with the wings. But you
bro.
know, I don't think I've tried it. Well, maybe I have. I don't remember.
Maybe,
But
maybe,
but
but
you
hey,
know, I don't know, dude. You're saying you
it's
dip
good
it
though.
though. You dip it like if it's ranch.
Yeah, you dip it, bro. You go all in, bro. You like you drench it up a little bit, then add some little bit of ranch on top, and then I'm trying to dominate the technique where, there's a flat and then
Technique.
the drumstick,
Uh huh.
right? Oh, you get the flat, bro. You grab it from like the very tip of the other end, and you put it inside your mouth, and you just like bite it, and you just like drag the bone like out from your mouth, and all the meat stays, you know. Like you
Yeah,
grab
bro. You
the
be
wing
watching
from
too
the
many
tip,
Instagram reels, bro.
and you put it all in your mouth. You just go, shoom, bro.
You need to get off
Best
those
feeling
Instagram
ever.
reels, man. Watching those tips and tricks how to eat
uh,
wings.
you gotta eat
You need
wings,
tips and
bro.
tricks on how to eat wings, man. You want to do it the fast way, bro? I want to
Yeah, go
enjoy
for it,
my wing, man.
bro. Nah, dude.
Why do you want to mess it all up?
Bro, I don't know. It's fun, dude. It's fun.
All right.
But I did burn my mouth though, because they were hot.
Uh huh.
And so right
See,
now my
look,
mouth, like the top of
you
my mouth, is
you're
like
trying to do
burnt.
too much with the wing. You're trying to dip it
Yeah,
in cheese and do
you're right. You're
the
right.
one bite
You're right.
challenge or whatever. And look at you, you burned your damn mouth. So
You're right. You're right. I think I chewed
come
more
on
than I could
now, lock
handle,
in,
than I can swallow. You know.
lock in. But you don't you get like
Ah,
only 8 wings though? You said
I get six. I get the
yes,
six.
mother
Yeah.
6. You get a kids
Yeah.
meal,
Bro, six is plenty, bro. Plus the fries, bro. Bro, Wingstop doesn't like joke around with the fries, bro. They go boom, boom, boom. That thing is stacked up.
bro. Got
So
a
with like
kids meal at
six,
Wingstop.
bro.
Does it come with a toy
Dude.
too? Damn, man, six
It does
wings.
come
I
with
don't
a
remember
toy,
the last
brother.
time I ate 6 wings.
Bro, it's
Or
cause,
like, can I get the
dude,
6 wings? No,
6 wings, bro. Three
10,
and
bro.
three, 10.
10.
Nah,
And
I can't
sometimes,
handle
hey,
10.
I can't believe I'm saying this online. Sometimes 20. I
Hey,
said it. I said it.
no, it's okay, bro. There's those days where you're like really hungry, bro. You really want to eat, and you can eat. It happens to me too. I sometimes eat like 8 or 10. You know, but for me, like, if I'm
Bro
a
said,
go,
"Oh, if I'm really hungry, 8 wings, man.
eight
Whoa,
or
what
ten,
the?
eight or
That's a
ten.
big jump, bro. That's crazy for you, man. That 2 extra wings. Oh, dude, you're really hungry, man. That is crazy. But my boy's starving.
Bro,
Bro, starving and gets 8 wings. Get out of here, man. You're crazy.
dude. It's cause, bro, it's cause I eat the fries and I eat the wings, bro, and that's like plenty for me. I'm stuffed up. I can
Yeah.
barely move,
All right,
you
man.
know.
Yeah.
But alrighty, yeah.
I'll
What?
keep it short real quick. I'll talk about my weekend real quick.
Alrighty, but
Weekend,
yeah, I was gonna ask you.
busy. You know, trying to do some
Busy, busy.
assignments, and then also, um, I think it was like a friendsgiving, like like a little event.
Okay.
Um, so I ate some turkey and some mac and cheese, and
Ooh.
you know, and it was really good. And but one thing that I try not to do is eat too much of Thanksgiving food prior to like my
Mhm.
family's, because I don't want to like go to my
Mm.
family's house and like not crave it, if that makes sense.
Yeah,
Like
yeah,
I
I
don't want
get
to
you.
go
Yeah,
there and like, oh, I already
bro, I'm
had
craving that
green. Yeah,
spaghetti,
all
bro.
right, man. I could go on with that right now, but I'm just gonna keep on going. I'm gonna ignore that. Um. So, anyways, yeah, that was it. That was the weekend, and it was really nice. So now when I'm
Yeah, that's
back,
good to
now
hear,
I'm
brother.
here.
That's good to hear.
Yeah. But
Yes,
okay, okay.
sir. All
Let's get
right, time to lock
started.
in, brother.
It's
Time to
time to
lock
lock
in.
in. We're doing house robbery, you said?
House
All
robber,
right.
the first one.
So if you are new here, we've been trying to do this list of questions, and we so far finished these right here. And we're gonna do these heap or backtracking, but I believe we decided to skip it a little bit and go to dynamic programming, um, for whatever reason. And now we're here, so we're gonna try to do this, and then hopefully we could do it in a good time. But let's get it going. Do we have
All right.
Excaligo ready or no?
Oh, I can set it up in a second, brother. If you want, you can read the question, and I'll get it set it up meanwhile.
Okay. So there's a medium problem. This is 198 House Robber, and it says, "Oh, what's up, Coin Flip? Yo!"
Yo, welcome to the stream, brother. Welcome to the stream.
It says you're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. So, given an integer array nums representing the amount of money of each house, return the maximum amount of money you could rob tonight without alerting the police. Mm,
Ooh, that's
interesting.
a good one. That's a good one.
So it's saying every adjacent house. Oh, each. Okay, let me just say the examples.
Yeah, go for it.
Input with the input of nums 1, 2, 3, 1. The output should be 4, because if you rob house 1, which has $1 or one amount of money, I guess you could say, and then you rob house 3, equals which has 3 in money, then the total amount you can rob is 4. for example, 2, let's bring this down. You got an input of 2, 7, 9, 3, 1. The output, the maximum would be 12 because if you rob house 1, you get 2. If you rob house 3, you get 9. If you rob house 5, you get 1. So the total would be 12. But
All right. Okay.
just
Coin
gotta,
flip. Just
okay, you got, do your thing, do your thing.
uh, I got you. Got you. Just got off work and wanted to watch something that feels productive. Glad if I could. Hey, I'm glad you're here, brother. I'm glad you're here, bro. Hopefully you enjoyed your time. Just relax. Enjoy the live stream. And hey, thank you for tuning in, brother. Appreciate it.
Yes, sir. Coin flip. Appreciate you, man. Hope hope work was really good or maybe not so bad. Really good or not so bad. Anyways. Alright. So that's house robber.
Mm-hmm.
Does that make kind of
The
understand or
yeah. Let me see. Let me see. Uh,
so if
let me
they're
see.
adjacent to each other, the two houses were broken into on the same night.
Yeah, you can either do 2 and 9, 7 and 3.
2 and 9, 7, 3. Yeah, so you can do houses that are side by side.
Yeah, you can't do 2 or 7 or 7 and 9 because they're by each other.
Hmm.
Yeah. We'll move fast. This is gonna be interesting.
So dynamically,
Well, let's first off
okay,
recursively.
first
Yeah,
recursively. Okay,
recursive.
my bad, my bad. That's on
Yeah.
me. That's on me.
All good. Hey,
Just
all
figure it
good,
out.
brother.
So I'm gonna just write it down, just so maybe people could see.
Yeah. I have it on
Step
schedule. I sent you the schedule
1,
already, so just a little. Well, it was good. I hope your
recursive.
days has been as well. Hey, our days. Well, me personally, my day's been pretty good. Restful, a little bit of restful. Doing a couple assignments for school, and I'm glad your work was good for you too, my guy. That's good to hear. Okay, okay.
Recursive approach. So I guess there will be a base case, right?
Yeah,
Base case. And hmm.
because there's. Let's see. Mm,
Base case. Would it be money wise or will it be
I think it would be lengthwise if we go over the length.
lengthwise?
Mm-hmm.
Hmm. So what I'm just throwing stuff,
Mm-hmm.
We can never do we can never iterate it through linear not linearly, but we can never do each house in a row, if that makes sense, right? Like we can't do 1, 2, 3. We always gotta skip after.
Yeah, because they can't be adjacent.
So I don't know if this makes sense, but would it be no, that's really bad. But you could do 1 and then 3 and then if that's not good, 2 and 1. Obviously that's oh that's n to the power of n. So that's really bad, right?
A little bit, yeah.
But that's the first thing I started thinking of is like that
Yeah.
brute force approach,
Yeah, yeah.
but a recursive one.
It's because I'm not sure because it doesn't specify. Because what if we can jump around and like we don't have to skip one house, we can skip 3 houses and then get the fourth one. For example, here,
Yes,
like
yes.
let's say the last one was a 4, right? Instead of a 1, would the output be 1 and 4? So 5? Or
Yeah,
would it still
because
be
that's the
4?
max. That's the max amount.
Exactly.
Hmm.
Exactly. So for this, I'm thinking Okay, so for this part, I'm not sure how this thing is gonna work because we have to skip. We always have to skip the following one, right? We always have to skip two, right? Or the following index because we cannot be adjacent to each other. So we always have to skip that index that we're next to. Does that make sense? Because we can be adjacent, so we have to skip it. So we can go to the second house or to the third house, but we cannot go to the next house. We always have to go to the next or next, but not next.
Let's see. Is it so? Is it? I know when we get this recursive approach figured out, and we want to try to do dynamic programming. Is this? Is there a memoing approach like
Mm,
or
I
what
think so.
some
Yeah.
like what can we save? Like the money we could save. Which house has?
I mean,
But
um,
it you. That's why I'm thinking. Like maybe you can't say that because how do you know if it's adjacent to? Um,
well, let's think about it.
do we need to
Uh,
bring out the drawing board?
I mean, yeah, yeah, for sure. Yeah, yeah, we
Do
can
you
do
have a
that. Yeah,
vision?
yeah,
Okay, let's
because I
see.
think the better approach would be starting a recursive, finding the recursive logic, and from there going to memoing, right? Because if you're trying to think of memoing right now without really knowing what the recursive approach is or understanding the basis, I think it could be
Do you
it
have the
could help us a
problem?
lot more. Yeah, yeah, I think yeah. I think I'm more up. I'm scratching.
Oh,
Uh,
yes.
yeah, you see me?
I'm here. I'm
Yeah,
here.
yeah.
I'm here. Yeah,
Okay, okay,
yeah.
okay, okay.
I got you. I got you. I got you.
I got you. No worries, no worries. All right. For example, let's take this one. Let's take example two. Um. Hmm. So we got, I'm gonna do a text box, because some people, they like the text box.
Yeah, some people like
Text box.
to. Never mind. I'm not
They
gonna.
know.
I'm not gonna do that to you. Thanksgiving's around the corner. I don't
Gotta
wanna.
be thankful. You gotta be thankful.
Yeah.
All right. So we got an array, right? Let me get this a little bit bigger right here. Right here. What I was thinking, right? Not sure. We create a for loop,
For
right?
loop. Okay.
For loop, right? A for, right? That loops through each one,
Mm-hmm.
right? And we call a recursive function, right? Depending on our parameters, right? This is my initial approach.
That's like the skeleton.
Yeah, yeah, yeah. I
Okay.
don't know
Okay.
what the recursive function is, but I think,
So
right?
you're thinking you iterate
Yeah, you're gonna
each
get this
one.
two.
You call the recursive function.
Yeah, you get two, and you send this to recursive function, right?
Okay.
And it's gonna this 9 and 3 and 1 because 7 we can't do 7 because it's adjacent to each other, right? So we do 9 3 1, right?
Oh.
You get me? You get me?
Oh.
And then 9 3 1, you send this,
You
you go
send
3
that.
1.
No, wouldn't you send this?
Oh, you send this, yes sir.
Yeah,
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 yeah.
yeah. So once you send 9 3 1, you send
You
9 and 1,
and one. Okay.
and then you go to 3,
Yep,
right?
yep.
But since you can't use this one, you just send 3. You
Wait,
choose
wait.
the
You don't go to.
maximum.
You don't go to three. Do you?
Yes, you go to 3 because you
Yes,
go to
because after
2.
you do this, then
9,
you got
yeah, you
next
gotta
one is
go.
three.
You go
Okay,
to
okay, okay,
3,
okay, okay,
yeah,
okay.
and then from 3, it's gonna say like, all right, bet whatever. You go to 1, right? You go to 3, and then
There's
3
nothing
there's nothing there, so we get the maximum of
of
this,
this. Yep, yep. Return it
and we
back
send it
up.
back to 2.
Oh,
Oh, baby,
dude, you're
okay,
onto
whoa.
something.
I
You're
think I'm
onto
onto
something.
something. 7, same thing. 3 and 1.
Mm-hmm.
Ooh, fast. Okay,
Wait a
give me a
minute.
sec.
Wait
Give
a
me a sec.
minute. Wait a minute.
Hmm. Hmm.
Wait.
'Cause I think I see a pattern for a memo. Oh, I'm not
Oh, I
sure.
know. I think I see it too.
You see
Since
it too?
like let this one like for example, I don't know if it works for, but for example, let's say 7 takes in 3 and 1. And 2, let's say 2 had the opportunity to check 3 and 1 itself as well. You store the max of
I was gonna say the same thing. We
something
store the
like that.
max of
Something like
3 and
that.
1, or the two values, 9 and 1,
Mm-hmm.
based on their indices. Not on the numbers itself, but on the
The
indices.
indices. Yeah.
Yeah.
Okay.
So, and this would be to the to the array,
Oof.
which is
Oofus.
not hard, which is not that bad.
I have nightmares of 2D arrays.
It's not that, I don't think it's that bad. It's just now we're without with working, instead of working with index, we're working with two.
Okay.
Yeah, pretty much. But let's first work it recursively, figure it out,
Okay,
understand the
okay.
logic, and then we can go to
So I have a
memoing.
couple questions.
Yeah.
As for like complexity wise, would this doing 2 and then you're getting this and then you're at 9 and you get the remainder of 9 if there's any. Would this be like a O and something? Like would it
Mm,
like since it's not necessarily like a
I
brute
mean,
force approach because you
we
are
have
like
to we have to take into consideration the recursive. So this for loop is gonna do
and
n, right? For the first topic, we're gonna do 27227 931.
yeah.
Then the next one is gonna do 931,
Okay.
right? And then the next one is gonna do 1. So as you can see, we're always subtracting 2, right? So it's gonna be n, and then this recursive is gonna be n minus 2, right? Because we're gonna jump to 7, we're just gonna loop through 931. And then we're gonna get 9, and we're gonna loop through 1 all the way to 1. I don't know if that makes sense.
Yeah. No, it does.
Yes. So I'm thinking it's gonna be n.
Would that be like dividing each time? No, right? In the recursive function, wouldn't it divide the size by 2?
Divide the size by 2.
Almost like a log.
Not quite, because we're just subtracting minus 2. A log kind of like divides it, like it goes 2, 4, 8, 16, 32, right? We go by the powers of 2, but here we're just subtracting 2.
Okay.
So I don't think it would be like dividing. Be more like subtracting. And I think it would be O of n, if I'm not mistaken.
Because or n times n?
N times n minus 2.
Drop the constant, maybe? I don't know.
It would be n to the power of something, that's for sure. But I'm not quite sure what it is.
Well, it's fine. I was just curious. I was
No, yeah, for sure,
in,
yeah. But I think we'll get a better understanding once we figure out the implementation
okay.
of the recursive. So let me delete this right here. We're gonna possible 4. So what I was thinking, right? I don't know. Well, let's see. Let's create our little diagram, right? And we send these two. Okay, so we get our. How do we do this? How do we do this?
So
Hmm.
we'll loop through the indexes.
Yeah. So we
Indexes.
get a. So our input is gonna be I,
I. And
right?
then
I meaning 2, right?
we're gonna get I plus 1. No, I plus
Plus
2
2, plus 2. So we're gonna do
to n,
no, because we're going based on the index.
which is
So
still n.
this plus 2 is gonna go right here.
Yeah, but we're gonna go from I plus 2 to the end, which is n. Yay or nay?
Yeah. But we can pass in the index because this array is gonna be global, right? Since it's global, we can just start our next function from here all the way over here.
I see what you're saying. Okay.
Yeah.
So
Yep.
it's
Yep.
an,
Yep. Yep.
so then the base case would be if it's over the length of some,
Oh, if it's over
if
the
it's
length,
out of the
yes.
index, then stop going.
Yeah.
Okay. Okay.
Yeah.
I see what you're
That'd be
saying.
our base case. Yeah, our base case would be if I is over n, or if it's over n, return
If
0.
will it be I plus 2 or I?
Well, no, because I is already this I already has it's an input. All right, it's an input of an index. So we already took into account the I plus 2,
Okay.
right? So in this
So
case,
before
yeah,
you
this
try to
case would
access
be
anything, you check if I is
right here. This
okay.
2 is gonna go in here,
Okay.
pretty much. Yeah. So that's gonna return 0. But if base, there's another one. I equals n,
Max
position
or
I. No, we're just gonna return it the value. Right. For example, if we're at 1, right, we're just gonna return 1 to the back. Right? Because there's no more numbers. We just know that 1, it's 1, and it is what it is. There's nothing more, right? Because it's we're at the end. We know for sure if we're at the end, there's nothing else on the back. So we can just return 1.
okay.
Yeah or nay?
That's a yay.
Yay? Alright. Okay, here comes the hard part, brother. So we're gonna try to figure this thing out. So we have I plus 2, right? We're gonna get, so since we want the total, right? The total of money, the maximum number that we can get, right?
Yeah.
Mm. How do we do this?
So let's break it apart. So we start
So we
with
get
I
2.
plus 2. We're at 9.
We're at
And we're at
9.
931. And
Okay. So
then
here we have to implement the for loop,
okay.
right? The for.
Another for loop. Or no?
No, this is the same one. This is the same one. We can delete this over here. It's the same for loop. It's the same for loop,
Okay.
right? Same for loop. So we got the for, boom, 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 right? Mm, let's see.
Is it the same for loop?
Yes, it is the same for loop. Yeah.
So how are we gonna start with I plus 2 if we don't have an
Well,
I?
this is for the recursive. So this thing would actually be more over here.
Okay.
Would it? Would it? Yes, it would be right here. Yeah. It would be right here. Boom. Yeah, because these curly braces represent our function, what we're gonna do. So we get the I, whatever I is, we're gonna add 2. Once we add 2, right, we either okay, no, plus 2 all the way to n.
And
So this thing is gonna equal n, right? thing is here we need to keep the maximum, right? So we're gonna have a max variable cut max.
Why did we put I plus n right here?
Oh yeah, yeah, yeah. You got me. You got me. You got me there. You got me there.
No. Hey. Consider me a never mind.
Uh,
A
like a
fail
fact
safe.
checker.
A
A
fail
fail safe.
safe.
There we go. There.
Yeah. Okay.
All right. Yeah. So we're gonna have a variable called max. Max. It's gonna keep the track of the max. That's why it's called max.
Do you remember the show called Max and Ruby? You might be too young.
No, I don't remember it. Max.
Maybe you're not too young, but maybe you just never seen it.
Oh, okay. I've seen the. Are they books? Do they have
Books?
books? Do they have
Maybe.
books?
Oh yes,
Maybe.
maybe.
Yeah, cause I've seen the books, but I've never seen the show.
That used to be my favorite little kid show.
Really?
Max and
Okay.
Ruby, yeah.
All right. No, I've seen the books. I've seen like the little booklets, but I've never seen the show.
Okay.
Okay. Fair enough. All right.
Did you seem like the type of a student that like always went all out in the book fair?
Nah,
Prove me wrong.
I didn't.
You wanted the all the main books and stuff like that.
Not the main books. If I think
The
when there was
Guinness
a book fair,
World Record.
nah, I would go for the books that had like little gadgets. Like came with little
Gadgets.
gadgets. Yeah, like I had a book about like Marines, and it had like a little tag and like, a little
Oh.
something else. But
Yeah.
with the book, so get that book for the tag, not for the book
Oh,
itself.
not for the book. Yeah, we
Yeah,
can throw away the book. Give me the
we
damn
can
tag.
throw it. Yeah,
I want the tag
exactly,
in it. Okay,
exactly.
nice.
All right.
I was
So
more
we're
of
gonna
a
keep.
chocolate calculator type of guy.
No.
Do you
Okay.
remember those?
Yeah, I
No,
remember
maybe.
those.
Okay, sorry. I'm back.
Yeah.
We're back. We're back.
I'm good. I'm good. So we got the eye.
Yep.
Okay, let's think about it.
So is this calling this again?
Yeah. This is gonna loop. This is gonna equal a function call that's gonna loop around and around, right? So here, but I'm here a little bit stuck because we're trying to keep the maximum, right?
Yes. So we for
Get
the
the full.
first iteration we brought in this.
Oh, okay. I got you. So it's I,
Yep.
right? It's gonna equal. I see. R, the array, right? Array
Array.
of I. So this is gonna equal to 2 in this case, right? Plus. Oh, I think I got you with that. You got me there. Yeah. Plus the function
Oof.
of.
Ooh, man, this guy's cooking.
Ooh.
Thanksgiving ain't even here yet.
Wait. No, this is
Wait a minute.
Wait. Let me. I have to reheat some stuff. I to n.
Recook.
I to n.
And
I plus 2.
plus 2.
Over here.
I plus 2. Okay,
Over
so
here.
we don't worry about this one right here.
Yeah. So that's that. So we're gonna get that.
And then it checks this. If this I plus 2 is greater than n, then it will stop this.
Yeah.
Okay.
Yeah. And here. Watch.
Or no, or this in general actually. This in general will stop. Max of
this and of max, which refers to
the variable.
Yeah, and this will set this to as well. But I didn't have space. But yeah, this max will set the other max to the variable max.
So it would be the max equals max.
Yeah, max equals max of
Or this function already does that, right? Because doesn't this tell it it's gonna go in?
No,
here?
you have to set max, so you go to max of this and this.
Okay.
Yep.
But
I think
question.
Yeah.
So we start at 2. We get this. Then we break it down even more. 9 plus. So we return 1. And
Uh-huh.
then from 1,
Turn to 1.
we
We
go
get,
back to 9.
yes.
And
Yeah,
then
because
we were.
9 is gonna be here, and the 1 is gonna come in through here. So now we got 10.
And then
So pretty much,
you say, is this greater than -1? It
if
is. So
so,
10
max, yeah,
is
equals
10.
10.
And then you bring it back the max of this,
Well,
which
yeah.
is
Well, now we done 9, right? We
okay.
do 3 and 1. Well, we do 3, right? 3 goes in, right? We already have our 10 in here, so 3 comes in.
But we skipped 7
Say,
though.
well, because we're doing 2 right now. Because
Okay.
2 sends
Yes.
all of this,
Okay.
right?
Okay.
So we do 9, 9 and 1, 10. We do
Then
3,
reiterate over.
right? We do 3, which is 0, 1, 2, 3. 0, 1, 0, 1. Well, this is 3. This is 1. This is 4. Yeah, 4. Right. So this is 3,
And this is out of index.
and that's out of index. Yeah. So that's out of index. I think this is gonna be 5. We come in here, which is 0.
0. 3 plus
We
0.
return this. 3 plus 0 is 3. Then we get the max this, and we keep 10. Right. Right, because we got 3. Now we got 10.
Yeah.
This is 3, 3, and 10.
Yep.
So we keep the 10, right?
Yep.
Now we do the 1 right here. We get 1,
1 plus 0.
1 plus 0, 1 plus 0, and the max of 10. We grab these,
Yep.
right? And we get 10. So we send back 10. And now, when we
Back
send back
10.
10, we got 2 plus
Plus
10.
10.
And we keep the 12 over here.
And then it goes to 7.
Then it goes to 7.
7
Right?
brings
7,
in 3
we
and
send
1.
3 and 1. We
Does
check
the same
3
thing.
and
Yeah.
0, which just returns 0. We get 3 plus 0, we get 10. And then we get we go to 1. 1 plus itself 1. Return 1. And we get 8. So we keep the 10. And we just go like that. Yeah.
Dude, that's nasty, man.
Nah,
I
brother.
think
Nah, nah.
my issue is thinking of the just
Yeah.
like trying to think of the idea of the recursive approach.
Yeah. Well,
I know like the
what,
steps to break it down, like, oh, you need a base
yeah.
case, you
Yeah.
need all this stuff, but like, well, how do I start?
Yeah. Okay. So here, I think it's just like figure out what the problem really wants. Because here, the one thing I saw was that, well, they can be adjacent,
Mm-hmm.
but the doesn't tell you that it has to be the next one of the adjacent, right? For example, in this case, it doesn't tell you it has to be 9. It could be 3. It could be 1, right? So
Yeah,
I know for
and that's
sure.
when you think of max. Then that's maybe when you
Yeah,
think of
you can keep max, yeah, you can keep a max, right? But you also can think of like, all right, 2 and 7. I have to skip this to 2 and 7. I have to make a split there. And then I can do, all right, 2 and 9 could be a possibility. 2 and 9 and 1 could be a possibility, right? So I'm like, all right, how do I check each possibility of 9, 3, and 1? Well, I need something that I can access 9, 3, and 1, which you can do so with a loop, right? So you go to 9, and then you go, okay, I have 9. What about 3 and 1? Well, I have to get a 1 then. And then it's just a recursive loop, right? Because as soon as you figure out 2, right? As soon as you figure out how 2 works, you figure out how 7 works, you figure out how 9 works, you figure out how 3 works, how you figure out how 1 works,
mm-hmm.
right? Because in recursive, you assume your implementation works, right? You assume this thing over here works for
Yeah.
all of them, right? So that's where I'm like, all right. So it's just, I feel like it's just recognizing like where the recursion is gonna be implemented in. I don't know if that
Okay.
makes sense.
No, I think you laid it
Yeah.
out perfectly. Like what you said here. I think we were both thinking, okay, obviously we're gonna have to skip. But for
Yeah.
me, I always think like, okay, it's gonna be you skip, you skip, you skip, and that's how it's always gonna be. But
Yeah.
you brought in, well, what if it's not necessarily 2 and 9, 9 and 1? What if it's 2 and 3, and that's
Yeah.
actually the max? Like let's just say
Yeah.
those
Yeah.
values make a
Uh-huh.
max, right?
Yeah.
So then this approach where it's always gonna be the skip, it's always gonna be that, that's not valid. So that's when
Exactly.
you would think
Yes.
of, okay, well, maybe you could get a max of it, like a max.
Hmm.
And then how,
Hmm.
what are you going to use a max for? Well, it's going to have to be multiple values, right? So then maybe that brings up the idea, okay, well, you could just bring in all of these and then figure out how to get
Yeah.
the max of that, and then maybe
Uh-huh.
you come to the
Yeah.
conclusion that, well, you got to break this down even more too. So then I see what it makes sense. It makes sense.
Yeah. Yeah. Yeah.
Yeah, it
This,
makes
yeah.
sense. So I think that
But
that's just
yeah.
something that I need to keep practicing for sure, is like
Yeah, for sure.
coming
And
up
no,
with the idea. And I know it's, you're not always gonna come up with the idea like the first time, but at least have like a structure approach
yeah, it's just
to create an
understanding the
idea.
structure of like how the problem is working, like how the problem works. And once you know like the structure of the problem, I feel like it's a little bit easier to understand how you're gonna approach it.
All right. I'm
Yeah,
talking
but
like if this is gonna be like perfect, like this is gonna run right now.
yeah, me too,
But
me too. But
I think
hey,
it
we'll
is. But
see.
watch us do it, and there's gonna be like some big bug that we have. But
Well, we'll
anyways,
see, we'll see. You know, trial and error, try and
yeah.
error. We'll figure it out. We'll figure it out on the way.
All right, we're
Okay,
here. We're here.
so
We're here.
we're here.
You want
Alrighty.
to start writing? You want
We'll
to? You don't? You can see the other screen, right? Like the
Yeah,
skeleton.
I can see the other.
Okay.
Yeah, yeah.
So guide me. Guide me.
All right, so we're gonna create a function.
Okay. Function. Are we gonna do the self stuff again or no? You don't want to do
No,
that?
I don't think so.
Okay.
Yeah, I don't think so. I think we're good. Okay, we can call it of f or
F.
yeah,
And
and
we're
we're
gonna
gonna
take
and
in an array.
a no, we're gonna take in a value,
I.
an index or I,
Index.
whatever you want to call it. Yeah.
Okay.
All right. So we're gonna do base case, which is get say if index is greater than return 0, or the length of length of nums. Yeah.
Should we have the length already set outside?
Yeah, we can do that. Yeah. But I think it's gonna be -1 though, because we're working with with the
Okay.
indices. Yeah, return 0. Then the other base case, if they're equal, return nums. Yeah. Uh huh. Yeah.
Okay.
And then we're gonna create a variable called max. Set it to equal to 0, 0, 0, 0. I think that is gonna be inside the for loop, inside
Okay.
the function. Yeah, cause yeah, equals 0.
Do you
Yeah,
want me
yeah,
to?
right
We
there.
won't have one outside.
Do we need a one outside? I don't think so, because every recursion call, it's gonna have its own max number. So I think it's best just to have it there, so it could,
Okay.
yeah.
Okay.
Then with that, we're gonna say for. We're gonna loop through the range for I in
I
for
plus.
in
No. No.
plus n, no, the length nums, range of length nums. +1 though, because this one we have to include the last one. Yeah, yeah. Hmm.
Okay.
So there we're gonna say max nums will equal to the maximum, to the max of f, well, of nums at I plus f I plus 2. And then
Something like that.
Yeah, like that, but pretty much. Yes.
Okay.
And then we're gonna return maximum outside the for loop. And I think it's max num on line 20. It's max oh no, max nums. You said it right there, yeah. And also over here in the back. Yeah. And then let's call it. And just give it an index
Wait, don't
0.
we? Oh, yes.
And return f equals e. Perfect, brother. Perfect. I think that's how it works. I'm not sure, brother. I'm not sure.
All right, let's see.
Maximum recursion depth exceeded in comparison. Oh
Remember,
man.
remember
Yeah.
what? Where we try the recursive approach, but we can't run it because
It's
it exceeds the right or no.
yeah.
So we gotta maybe assume that this is right if we want to do the memo.
All right, fair. We can do it.
Or do you want to print it out and see like when it stops?
No,
And
it's
see if
okay. It's all good. I think it's because it's very weird because 1 2 3 1 is not that big.
well, that's correct, but I guess you're right. Yeah.
It's not too
Okay.
big.
What's up with this? I'm already getting upset. All right.
Huh?
No. I was upset with the way the layout was. A line repeated. Okay, maybe
996 more times.
Okay, maybe there's something wrong. In range n plus 1 for I. In range.
That's very.
This starts at n, which n is always gonna be. So I think this is wrong right here. When you started from
0. Yeah,
when you
0.
started
No?
at I. Or at index. When you start at index to n plus 1.
You're right. Yep. You're right.
Or
Yes.
we just say
No.
index. We
Yeah.
started at
Index.
no, because it's gonna start from
Index.
0.
Yeah. It's
So
index.
index.
Yeah. You're right. Nice catch, brother. Nice catch. I think that's it. Oh, nice catch, my guy. Nice catch, bro. You are the failsafe. You are the failsafe.
I'm the
Damn,
failsafe, bro.
I was gonna catch that.
I'm the failsafe.
Ufas. Yeah, nice catch. Nice very catch. That's yeah, it totally blew my mind. It blew. Wow, okay. Hey, nice catch, brother. Hey, all right. I see you. You're
Nice.
locked
I'm
in.
locked in, baby. I'm plugged
You're
in.
locked in.
I'm plugged in. I'm the real life. I'm a human. That actually sounds really crazy to say, but I'm a human chat GPT, man.
Oh, damn, bro. All right.
Oh.
All right. Let's see. Oh, I think this one's gonna. Oh, they're different test kit. Okay, I thought they were.
I'm a human GPT. That's funny. It's funny because humans created the GPT, so it's just I don't know. Anyways,
I'll get better.
let's see.
Okay. Oh, this is gonna take long. I know it's gonna take
We might be cooked.
super long. We might be cooked. We might gonna be here sitting like, might as well eat some tea or something, drink some tea. Yeah, time limit exceeded. Yeah, we need to create a memo.
A memo. You want to just create your own, like
Yeah, we can do like whatever numbers.
okay.
All right, try this one.
All right.
Try 10
Oh,
and
test case.
yeah, try instead of 24, put a 1. Output should be 19, I think.
Dude, you're a human
Sure.
GPT, bro.
Nah,
You're a
brother,
human GPT.
nah. I ain't no GPT, brother. Ain't no GPT here.
That was funny. Remember when the hackathon were like, list your team members. Chat GPT, Clyde,
Cloud,
Gemini,
Aldo, Gemini, GitHub
Jose
Copilot.
Carlos, Jose Carlos.
We were on fine print at the bottom.
Yeah. Honorable teammates
Honorable
include
teammate.
GPT and Clyde or Claude, whatever its name is. Okay, so how we? It
Okay,
would
one more
have to
test case. One more
be
test
okay.
case.
One more time. Okay, one more time.
Okay. Apart right there in the third one.
Okay.
Add a 10.
Add
Add a 10.
add a 10.
Okay, fair. It works. Okay. Okay. Yeah. Okay. Okay. Okay.
Okay. So do
Okay.
we?
Fair.
Since we got the recursive approach,
We need
when it
the
comes to
memo.
memoing, we could add it to this, or do we do the dynamic
We
programming
can add it.
approach
We
with?
can add it to that. Yeah, we can add it to that. Yeah.
Okay, so that means
So that means we need
hold
a.
on.
I think we need a 2D array. Oh. I don't know. Do we need a 2D array? Oh no, I'm not sure how to do the memoing for this one. Because I don't. What you thinking, my guy? What you thinking?
Um, don't you just need to store the F4? The max of that is gonna be 5, or for example, like
Yeah.
max. So couldn't we just store the I+2 in a dictionary and store the max that's gonna be in it? Because we're gonna run into.
Oh, okay. I see. I get you.
Mm-hmm.
But yeah, I think
Bro,
so.
plug me in, man. I'm plugged in.
Yeah, I think we just.
We haven't even tested it out yet.
Dude, we're just like plugged in, bro. You have like 2 outlets, bro.
Yeah, for real, man.
Let's see.
What do you think?
So if you go by each index, right? Let's go like, for example, if you go back to SkettyDraw.
Yo, we just got a sub and it showed up for once.
Yes, sir.
Dries. Sorry if I mispronounced that, but thank you for subbing. This is our unusual stream time. We stream every Wednesday at 10 a.m. Central Time. That might not work for you, but thankfully YouTube, you can rewatch stuff if you want. So if you'd like, just rewatch it. If you don't like it, then you don't have to watch it. Whatever works for you, it don't matter.
Yes, sir.
But we're here every week. Every week.
Hey, sure. To one of your classmate, teammates, friend, bro. 1 away from 450. Come on.
Oh yeah.
1 away from 150.
There. 450. Right? We're almost
there.
there.
You know how satisfying that is to be like that even number, or that 1.
Jose, I
So
never
might
thought
be your
about
time.
that.
Hey, I
Like,
don't know how.
cause I don't know if you know, but like back in the day, middle school area, if you were like the 100 sub or the
Mm,
500 sub, like that's a
mm.
flex.
That is, it feels
You
like it
go,
feels satisfying. Like
you
you
tell
feel
your
like I'm the
friends like, I'm
exactly,
the actually the 100 sub. Like, did you
exactly.
did you
So
know
come
that?
on, exactly. You can be the
And sometimes,
450.
um, for any middle schoolers that are watching, sometimes you could use it as some game. Like you could be like, hey, like I was the
Hey.
100 sub. What you know? What you know
You show
about it?
them the clip. Show them the
Show them
clip.
the
We'll provide
clip.
you with the clip. We'll
Yeah,
put
we'll
you
send
to
you the clip if you need. We could verify too. We'd be like, hey, Dreas was the 450th
the
sub.
50th
Hey,
sub.
he's a good person, or it or she. Maybe it's a
Yeah,
or whatever, whatever. I don't know.
we'll talk good about you. We'll talk good about
Whatever
you.
it
Don't
is,
worry.
we will say they're a good person. Like we know them.
Exactly.
They helped us in need and stuff. Like we'll vouch. We'll vouch,
We'll
and
vouch.
you gotta
We'll vouch.
work. And trust me, me and
Exactly.
Jose, we're the best like wingmans that you need. So
Of course,
don't worry
buddy.
about it.
Of course. Don't worry. Don't
So
worry
just know
about it.
subbing, like you're getting a long time connection. Like a long
Mhm.
time connection that can
It's
help
a long
outside
time.
of coding.
Yes, sir.
So
Hey,
don't you worry
we're
about it.
we're a jack of food trades. We help everywhere. We help
Yep,
everywhere.
yep, yep, yep. And we'll
All
make it
right.
as a function. So if that one doesn't work for that person, you could just do it, apply it to a different person. That's a function. You
Hey,
could
I took
change
you.
the input. Change the input.
Exact.
It doesn't matter. Sometimes inputs return like maybe it's not the maximum. Like it's not the max that you
Exactly.
wanted.
It's not. It's not.
So
It's not set to true.
yep, yep, yep. So
The
you want to
return value
just
is false.
yep. You want to change the input. Boom. You can apply it to a different input. We'll vouch the same way. It don't matter.
Yes,
No
sir.
infinite loops, no
No
syntax errors, nothing.
exceptions. No
We
nothing.
got you. We're there.
It's a win-win situation.
With that being said, subscribe one more time on a different
Subscribe one more time.
on a different account, please. Okay, where are we at? I'm sorry,
Oh,
I got
all good.
sidetracked. That's me.
All good.
I'm just
Hey, no worries. No worries. You good.
I don't know.
I
Sometimes I
also
get
get
sidetracked.
I also get sidetracked, brother. And it adds some like flair, some flavor.
Oh, flavor, yeah, yeah.
Yeah. Okay, so I think we get it by the indices. Like we figure out, for example, we get an index and we check if we already calculated that index. If not, we save it in the memo. Don't know if that makes sense. For example, this 110, we're gonna do 4, 9, 110, right? With 4, we can save the maximum for 2, right? Because that's index 2, right? And then also with 9, we save the maximum for 9, the maximum for 1, the maximum for 10. And then when we go to 10 to 2, we're gonna go to 9, but we already calculated 9, so we just grab it. We go, shoom, right?
Yeah, so that would be f of 9, f of
Exactly,
so
exactly.
nice.
Yeah, yeah, yeah. I
Ali,
think I think that would.
how you doing,
Hey, welcome,
Ali?
Ali. Welcome to
Hi
the
with the left
stream.
parenthesis.
With the left parentheses,
Just a left parenthesis. I don't know
just
if
a
that's like
little.
code for something or
I think she just like forgot to put the other parentheses.
I don't know, man. I think it
What the
might be like
heck?
some subliminal,
Some subliminal.
some subliminal message. Once we figure it out, we'll
We'll get back to you.
we'll get back to you on that one. But okay, so
All right.
dictionary then,
We can
or
do a
what are you thinking?
dictionary and array.
Array? Okay,
Whatever you
well
want to
if
do.
you want array, let's do array.
Alrighty.
Okay, so
It's called it memo.
memo
-1
times
times n. Wait, times length
times
nums
n.
or n plus 1.
So,
Parentheses up. Parentheses.
parentheses,
Parentheses.
parentheses.
Yeah.
Can't forget.
Yeah.
Okay,
So
then
now
would it
it's
be
after the if statements.
after the if statements?
Yeah, right there, right there, right there.
Mm-hmm.
Then we're gonna do if memo position index It's not and not equal to -1.
And
Return memo at index. Okay, then if not, we go to line 26 and we save the value. We still return it though. We still return it because the other function calls
so
needed,
do we save
but
it
we
in here?
just we set it outside the for loop. Right there. Yeah. We're gonna do
So
memo at index.
wait.
No, it was a mistake.
Oh yes.
Fair enough. Fair enough. We're about here to decode this the high
Goes
with left parentheses.
like that.
Yeah. Yeah.
You think that's it?
I think so. Run it.
Okay. Where's our other test cases?
Okay, so here I think there's gonna be a small problem
What are you thinking?
because we're returning f of o, f of 0, but what if the maximum number is not in the first index? Right, because we're returning f at 0, right? F at 0, right? We're gonna send 0, and it's gonna do the computation. Oh, never mind.
It's still gonna iterate to the next one, correct?
Yeah. My bad. Yes. It's gonna iterate to the next one. Yes. Yeah, that makes sense. Yeah, we're good. We're good. We're
Wait,
good.
wait, wait,
We're
wait,
good.
wait, wait,
No,
wait.
yeah. Because we
You
sent
put
0,
0,
right? We put 0, and it's
and
still
then
gonna
in
go to
range
0 all the way
from.
to the 0 all the way to n, right? So it's
Okay.
gonna loop through all of them. It's yeah,
Okay.
and it's gonna keep track of which number gave you the highest. All right, let's go. Oh, we're going all of them. We go all in, but
All
okay.
in, man. Hey, hey,
Baby.
hey, hey,
Hey,
hey,
hey,
hey.
hey,
That's what we're talking
hey,
about, baby.
hey,
Good
hey,
stuff.
hey.
That's what we're
Oh
talking about.
man,
Runtime
brother.
3ms, apparently.
Woohoo! There you go. It's not 0 anymore.
Or no.
Bro, good
Dang, man.
stuff,
Good
brother.
stuff.
Good stuff.
We locked in, dude. Dude, I don't know about you, but I like dynamic. No, I'm not saying that. I'm not saying that. What?
Come on, brother. Say it, brother.
I'm not
Say it,
saying
brother.
that. You know why?
No.
But it's gonna bite me in the butt.
It's
I'm
because
gonna say
it is
like,
pretty fun.
I'm gonna say like, I like dynamic programming. Oh yeah, and then next time I do it, bro, I'm just gonna be the worst ever.
It's because it's pretty fun.
But
It's
I like
pretty
the
fun.
journey, if that makes sense. The journey
Yeah,
of
yeah,
dynamic programming is so satisfying. Like
yeah,
it feels more. I feel more accomplished doing a
yeah,
dynamic
yeah,
programming than like a binary search or like a
yeah.
breadth
100%.
first search or anything like that. If that makes sense.
Yep.
Dang man, that's crazy.
Damn, bro. Oh,
Okay,
fast,
what
bro.
about what are some edge cases maybe that we're not accounting for or
I mean, check the constraints. Let's see, because I don't think we're gonna get any zeros. Oh, if we okay, okay. So at least we have an element in there. So I think we got all of those good. Yeah.
all right. So this is still like recursion though, right?
I mean, it's dynamic with recursion, right? It's not fully dynamic because we are still depending on recursion,
So
but
dynamic
it
would
is
be if we're using the array.
if we're using the array with
Just an
no like recursion at all. Yeah.
Like a Fibonacci.
The
No,
Fibonacci,
not
yeah.
not necessarily like a Fibonacci, but like
Yeah.
actually maybe no,
I mean,
because
Fibonacci, you can do it in all three ways.
Fibonacci you input a number and it would calculate it from there. And there's no set array, right? Or wait,
You can because you need two base cases, right? Which is two previous numbers, which are 0 and 1. So you go 0 and 1, and you start at 2. So 2, you just get 2 minus 1 of the index minus 2 of the index. You add them up, and you get 2. You move to 3, go to 2 previous ones, and then you got
but I
3.
thought the
Then
Fibonacci
4.
was you input two and then it'll. Oh no, wait no, yes no. I don't remember. Don't care. Sorry.
Okay, fair enough.
Um. Okay, so then what are we doing now? Since we solved this.
I mean, we can do it dynamically with no recursion.
Wait,
And
where's the
then after
show or
that,
submission?
oh, we haven't submitted. We have run it.
Oh,
We ran it.
oh. I thought for a second it was gonna. Okay. I thought for a second we're gonna erase all our stuff. What are you thinking? We
Run it.
submit it?
Submit.
Okay, let me run it real quick because I know I messed it up a little bit. Submit.
Hey, hey,
Hey,
hey,
hey,
hey, hey,
hey,
hey,
hey.
hey, hey,
You know what?
hey.
We're in the 49.3. Is that correct?
No, we're in the 51, no? Because it has acceptance rate of
Yes.
51.7.
We're in the
Yeah.
51.7.
Percent. Actually, I thought we weren't gonna able. I thought we were gonna have a lot more difficulty trying to
For
figure it
this
out.
being a medium, the approach was fairly easy. Well, oh my gosh. See, look. Now you see how I'm talking? You see how I'm talking now?
Bro, you're talking all
I gotta
big
stop. I
now.
gotta stop myself because I
Bro,
don't. Like I said,
you're gonna put in the comments. This should be an easy problem.
yeah, like
Uh,
I'm acting like that. But if you reverse back, I'm all quiet during the approach and stuff. I'm quiet, silent. You know, like so. I need to
no,
stop
no,
talking.
no.
I need to stop
No,
talking.
you helped with the index, because we're getting some recursion errors, and you helped with the figure out the memo. You
See,
know?
I think it's but the general approach is where I mess up. It's like thinking of it, but obviously,
Yeah.
whenever you're breaking it down, whenever like you're talking it, is I could already see where you're heading with it after
Mhm,
the
mhm.
initial after the initial idea that you get.
Yeah. Yep. Yep. Yeah.
Okay, so
All
how do you
right.
want this? Do you want to just
Uh.
go into the next one, try the next one out,
You tell me, brother.
or it's time telling us, yo, we got class at 8:30 tomorrow a.m. We got to make sure we're getting enough
Jeez,
sleep.
bro. I'm getting a little bit hungry, brother.
Okay, hungry. Maybe hungry is the
Yeah.
excuse.
Yeah. But I mean, I'm down. Maybe what if we make it fully dynamic with no recursion? Give it like a 10 minutes, 15 minutes, see where we can go. And after
Okay.
that, we can call it a day.
Okay.
I don't know how you feel about that,
Yeah,
my
let's
guy.
do that. Step
Yeah, all
3,
right.
turn the solution to full dynamic, I guess. Whatever.
Yeah.
Okay. 10 minutes on the clock.
10 minutes on the clock.
10
Damn.
minutes on the clock.
Okay. So for here, mm,
How do
let's
we
think about.
how do we do the other one again with the array?
Oh. With the array, we had to create an array, and we had to use our base cases, right? To or we had to create our approach or base cases to figure out the next value, right? Here, this is interesting because we're gonna go backwards. Instead of starting at 0, we're starting at the length. I don't know if you can see it.
Don't tell me.
I'm not gonna tell you. I'm not gonna tell you.
Is it like f of n? Is that what you mean by length, or
F of
index,
length.
max? I'm thinking about an array. It's gonna store the numbers. You're gonna go backwards. This, you say you're gonna start at the end of the array. Is that correct?
Yeah, I think so. Let me see. Let me see.
But
I
what
think
do
it.
you
I think
mean?
it's. Look, I'm gonna give you a tip. Look at the base cases, and then line 25. Because that's where you know how we're working. You know how in recursion we assume the approach, right? To get to our we assume the value is correct, right? We assume the how do I let me see. Let me remember. Okay, yes. We assume the approach, like the function, like the +2, right? We assume that to get a value. That's recursion. Recursion dynamic is backwards. We get the value, right, by using, right, our approach, which is the base cases and the I+2, right? Knowing this information, knowing seeing how we're right, how we're progressing, think about it in this way. Um, how are we moving? What are the values do we depend to get the new value? Are they the value behind the value that we're trying to figure out, or in front? I don't know if that makes sense. Like, do we depend on,
We're
let's say we have
depending on
index.
we're depending on the front,
I mean, are you
right?
100%?
Because you
Yeah.
start at index and you want to. For this case, we're depending on I+2. Yay or nay? Unless I'm understanding you
Yeah.
incorrectly,
Yep. 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 Yep.
which that would be in front.
Yes.
Unless you're depending on. No, that's honestly that's how I see it. But what were you thinking?
Yeah, I was thinking. Yeah, I was thinking the same thing. We're depending on the front, so that's why we have to start backwards. That's the approach we want to figure out. How are we gonna go? Are we gonna go left to right or right to left? I think we should go from right to left. Yay or nay?
Hmm. So okay, so recursion starts top, goes down to the bottom.
Yeah.
Dynamic starts from bottom, goes up. Yay or nay?
Yes. 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 Yes.
Okay.
Yes. Yes.
So if our top to bottom in the recursive was getting the big array, breaking it up into I+2 and to n, and then doing I+2 to n and breaking it down, we got to start from one single uh, index and add more until you get to the big array.
Yeah.
But that's just assume that's just thinking about it like that. But I don't know if that's correct or not. If you start from the singular, hmm.
Yeah. I look at
Oh,
it more like what values do we need? Like if I want to figure out this value at this specific index, in what values do I depend on? The front or the back? Because if it's in the back, we have to start at index 0. But if they're in the front, we have to start at index n. So which values do I need? The back ones or the front ones? For example, in this case, right, we're trying to rob houses, right?
Yeah,
For
yeah, yeah.
example, let's take on 9, right? On 9, yeah, right there, 9. Um, if I want to figure out the maximum number that I want for 9 or for that index, where do I go? You go to the front, right? So I need the values in the front to calculate myself. Yeah or nay?
I'm not quite understanding. Like, I know
Uh-huh.
what you're saying, but I'm not quite understanding the benefit of doing this way than what we already did. I'm not understanding, like,
Like the dynamic?
yeah,
Like why we need that why do like why not stick to recursion?
yes.
Yeah. Well, recursion, remember recursion takes up memory,
Mm.
right? Like every
Okay.
recursion call, you create you create a for loop, right? You create different indices. So every recursion call takes up memory, right? With dynamic, just get arrays, right? And arrays don't really take that much memory. And also the lookup time of a value. For example, recursion, you have to wait for the recursion to finish, right? In dynamic, you just wait once, right? Because it's gonna calculate all the values, right? And then after that, you can say like, oh, give me uh this value, and it's gonna give you the result for this value or this value. It's gonna give it instantaneously. Why? Because because it's an array. An array has a lookup time of 1.
Yep.
Over here in a recursion, you have to wait on for all the recursion to finish, and then it's gonna give you the value. Give it another value, it's gonna do all the recursion, then give you a value. So it's just like dynamic just takes away that time and that space that recursion takes up. Yeah or nay?
I see what you're saying.
Yeah. So that's why like I'm not really sure. I'm no expert in this, but like I think dynamic not all problems are dynamic, but dynamic usually is like a little bit better than recursion.
So how do we
But
start from the end and bring it to the front and like, because one thing is like, what special way can we do that's just gonna do 1, 9, 2, or 1 and then get the max of this? Like, I'm completely, I don't know.
what do you
Uh,
mean get the max bit?
like, you're saying start from the end, but how are we gonna do this without recursion? That's that we're gonna figure out the max.
Well, we can do a loop, right? We can do a loop where we start at, let's think about it. Let's think about it. So if you can, I have it here in the Scully draw. I have it over here. I
Oh,
don't know if
okay,
you want
okay.
to
Let's bring it over
visualize
there.
it a little bit. Um, so we have our recursion 1, 2, 3, 4, 5. We have 5 values. 1, 2, 3. Yeah, 5. So we have here, we for sure fill in the 1 and the 3, right? Because the 3 is going to go over here, which is invalid. So it's just 3 plus 0, right? 1, if it goes over here, it's invalid. So it's just going to be itself, right? So here we can do, all right, we can scratch those 2 out. I'm not really for 100% what the dynamic solution is, but I think it's going to look something like this.
Wait, you're on to something.
A little bit, a little bit, a little bit.
Wait.
So now we get the index, right? 0, 1, 2, 3, 4. We say, all right, grab index 2, right? We know for sure we have two indices already set. These two, we already have them set,
Like these are the
100%. These are the
max
these are
for
the
these
base
two
cases.
indices.
Yeah, no, well, not the max. They're just
Oh,
the base cases,
okay.
right? They're the base cases. So I can say for sure, give me 2 minus 2, right? Because I can't do the adjacent, right? So I do 9 plus 1, 10. Boom, I got 10. So the maximum number of this array of those houses is 10, right? Now we take on 7. We take on 7, right? Here's where I struggle a little bit. I'm not sure what the solution is, because we can do 7 minus plus 2. We do plus 2. 2 plus 2, right? Because this is right. So 1 plus 2 is 3, right? Which is 10, right? Yeah or nay?
Wait.
Wait, yeah?
One plus. What did you say? One.
7 plus 3. 7 plus 3,
Okay. Okay.
right? So that's the maximum we can get, right? But notice
But
this.
you're
Notice this.
checking it with these two.
No, I'm checking it with the ones I have over here, right?
Yeah,
Because
but
check this.
okay.
Uh-huh.
Like you're doing. Keep doing.
Yeah. So let's retrack a little bit, right? Let's retrack a little from the start, right? So 3 and 1, we for sure know that they're gonna be their values.
Yep.
100%. They're gonna
Yep.
be their values, right? Because of the base cases.
Base cases. Yep. So that's the
Now
max for them.
that's the max for them. Yeah,
That's
that's the
the
max for
max for
3 and that's
them.
the max for 4.
Okay.
Yes. We go to 9,
Mm-hmm.
right? According to our approach, we do 9, we get the index 2, and then we add 2, right? Because we can't do the adjacent,
Yep.
right? So we do 4. 9 plus 1, 10.
10.
That's the maximum for 9,
For yep.
right?
That's the
9,
maximum for this.
right? Now we go to 7. 7 plus 2, 3, right? So we're going to get 7 and the value at 3, which is 10. Yeah or nay?
Yay so far. Yay so far.
Yeah. All right. So notice this. 9, every index is already keeping its maximum amount of money
Yes.
we can store, we can take, right?
Mm-hmm.
So now when we go to 2, 0 plus 2, 10. 2, right? So we get the value of 10 and 10, and that's 12. And that's our maximum value for that index, right? So we return 12, right? So now we have all the maximum numbers for all of the values.
Yep.
Right?
So you return the biggest one.
We return the biggest one, which we can keep track of. Which we can keep
Which
track
we
of
could
with a
keep track of at
max.
each iteration.
Yeah, we can keep a track of 0.
Okay, I have a question.
Yeah.
So right here at 1, right?
Uh-huh.
We said, oh, index 1 plus 2, since we can't do adjacent, it'll be 10.
Oh, okay. I see what you mean.
But
Okay.
what if?
Yeah. What if there's more? Yeah. Okay. I see. You see, that's the problem I was facing. Because, like you said, we can do more. Well,
But you brought
we
up
can.
saying LaMelo baby.
Hey, LaMelo going crazy, bro. This
Hey,
man is
you
cooking
did.
up
Hey,
people, bro.
you did tell us. You did tell us.
Damn, bro. Damn.
That's crazy. LaMelo going crazy, man.
You go with the handles. Ooh, ooh, ooh.
Jose, hey, I seen Jose play basketball. He got a LaMelo. He got a mellow.
I got a mellow inside of me.
Yep. One game he made the clutch last shot.
Yes, sir.
He won the game.
Yes,
Backboard.
yes.
Bank was open.
Backboard.
It was crazy. It was like he looked like LaMelo. That's the crazy part of it.
Lamelo.
But hold up, clap.
All
We're
right.
almost done. We're locked in. Cause, anyways, but we might let
Yeah.
you. We might let you hop in. But
We
let's see.
might
We're,
let you.
we're
If
trying
we
to
if we're really stuck, we might let you.
we're trying to get it. Okay, Jose. Sorry, I distracted you. I'm sorry.
I got. So yeah. So what if we had like an 8 over here, right?
Wait,
Well,
wait, wait, Jose, Jose.
well. You saw what I'm saying, brother? Oh, you
No,
saw? You saw? No.
almost.
Okay.
Maybe the
Let's say
max.
let's say we have an 8 right here, right? And you're asking, well, what if, right? What if 7, right? We
Hmm.
only pay attention to 3, right? We don't pay attention to 8, right? Yeah or nay? Was that your question?
My question, yeah, was
Yeah. Yeah,
was
because
you
we
you immediately assumed that this one was gonna be the best for
uh-huh,
7.
uh-huh. Yeah, okay. So like we said, we set the base cases 1 and 8,
Okay?
3 and 8, right? 3 plus 2, 5. So we get the value of 5, which is this 8, and add 3, which is
It would
11.
always be the max.
It always be the maximum for each index. So we for sure know that for each possible index, we got the maximum, right? So for here 4, we get 4.
Ooh.
Hmm.
Ooh.
Here I don't like this.
Wait. Where you at?
I'm a 9.
Where?
I'm a 9.
9?
I'm right here. 9. 9 plus 2 equals 4. But you can also do 8. Hmm. I don't like this.
Here's what I was thinking.
Yeah.
But there is some complication that I gotta figure out. Is what if as you keep going, you're storing the max, which covers all this. But my question is, how would you know if the max would be adjacent to the current index you're at or not? Like for example, the max would be 2. I mean, would be 11 right here. But if you're
Hmm.
checking 2, you can't use this max because it's adjacent. But that's kind of my
Oh, for
thinking.
example, like if we had like a 13 here.
Yeah, and you're like, okay, well, I restored the max of all these because you have it in here. So you're like, okay, we'll just add it to the max. But the max was 11. So
Mhm.
you can't add
Well,
both of them.
we're always calculating each value right here of each
Mm-hmm.
corresponding number, right? So we can just keep a track of 11, of this one, and of this one, right? So let's say we had a 13 here, we got 11, but over here we got a 13, we saved the 13. Over here we got a 12, no. Over here we got a 15, we saved the 15.
Ooh.
Yeah, that's the way I was planning to, but here, not sure. Not sure how I'm approach this because you did get me there.
Hey, fail safe, baby. That's my
Fail
nickname.
safe, fail safe. Yeah, because this is gonna be 11, right? Because 7, 3, 8, but it can also do 7 and 1, which is 8. Or it can also be 7 and 8, which is 15. I think we just have to. No, that's complicated. That's a little bit complicated. Yeah, I think dynamics is a little bit complicated. what if?
We're on. You were onto something.
Hopefully, I think so. Let me see. Let's say we had a 0 here. Right, and we started from.
Can I erase these arrows?
Yeah, yeah, yeah. No, I'm kidding.
Just
So let's
draws the
retry
arrows
again.
again.
Uh,
So okay,
no.
I think we should reassess 1-8 base cases. Those are always going to be there.
Yeah.
You go into index 3. You know
Mm-hmm.
you can't use 1,
So you go to 8.
so you got to go to 8. But you also check, is there a higher number than 8 on there after? But is there a way
Yeah.
we could assume that that at index 3 plus 2, that this will be the max of everything prior?
Yeah. 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 Yeah.
We gotta we gotta be 100% sure that that's gonna be the max. So let's just say so far it works. So far we're like, all right, 3 plus index 3 plus the value of index 5, that would be 11. Okay.
Mm-hmm.
Then we're gonna go to 9. 9 plus 2. I mean,
Which is
sorry.
10.
Index 2 plus 2, 4, 10. But at index 4 is at the max. Like, and it's not. There's an 8 over here.
Yeah. Mm-hmm. I think we just have to loop through all of these. Like 3 plus 8.
Could you do, correct me if I'm wrong. Could you say 9 or could you say ARR at 2 plus max, and then it would be like ARR 2 plus 2. Let's say 2 is I or whatever, right? I guess let me fix it. I to the end. So it will get the max of the remainder.
Well, the thing is that it's based on multiple numbers. Like 7 can go to 3 and 8.
Yeah, but remember that these values will hold the max. If following this, this value will hold the max of whatever's behind.
Oh, okay. I see. Okay. Yeah. I see. I see. I see. I see you. So you're saying pretty much from 9, right? For 9, we get the maximum of 1 and 8,
Yep.
right?
Yep.
Then we get 17. Uh, we get 17, right? Then we get 7. we get the maximum out of this, which is 18, right?
Which would be 11.
7 plus, yeah,
Like,
see, yeah.
oh,
Yeah,
I'm
yeah,
sorry.
yeah.
I'm sorry. I'm sorry.
And then 2 would be from 17 all the way to 8, which is 19.
Mm-hmm.
Huh. That's, oh, bro, you're getting the hang of it. Yes, sir.
Am I locked in? Am I
You're
locked
locked
in?
in, bro. You're plugged
I'm
in.
plugged in, baby.
Yes,
Now,
sir. All right,
but I
brother.
think that this wouldn't it just be the same as what you said? You said you're gonna just loop through each one to see which one's the max.
Yeah,
That's
a
literally the
little
same
bit.
thing.
A little bit. Yeah, a little bit. Yeah, where we have to find that. Well, it's because I was trying to loop through this, through the actual array, like through the values. What you're suggesting is to loop through the values over here, which is a lot better.
Oh, okay. I see what you're saying.
Yeah. Yep. Yep.
Okay,
Yep.
okay.
Yeah. All right, brother. Let's implement this.
All right.
All right. I don't know how to implement it, so we'll see. We'll figure it out.
Okay.
All right. Let's comment it
So
all out.
yeah, comment.
Start at the bottom,
Start at the bottom.
and we're gonna do. So we need an array. Int
Array.
array. Call it memo. Memo again. Yeah.
Memo.
We go to -1s times 0 times n times n times n.
N minus 1 or
Like, well, we removed the variable over there,
n plus
so we
1?
have to bring it back. Yeah, we have to. Yes, yes, yes.
Okay.
Right there. Yeah. So we got the variables. So now we're gonna go enter. Oh, okay, so we're gonna loop backwards. Oh no, that's not good. For I, for I, in range of n, comma 0 minus 1, 0 minus 1. Oh no, instead of 0 it's gonna be -1. Yeah, then comma -1. No, n comma -1 comma -1. You can add an extra -1 because
Okay.
what that -1 is
It's
gonna
and
start
it's
from
going
n.
backwards.
Yeah, 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 yeah. So we're gonna click colon, and then
Wait,
enter, and
why are
then
we
we're
going
gonna,
to -1 though?
because it's because for this for
Like
loops
right here.
it ends before. It doesn't end at -1. It ends at 0. It always ends 1 before. It starts at n, but it ends at at the ending value -1, or the one before.
I see what you're saying.
Yep, yep, yep,
It's
yep.
exclusive.
Yeah, yeah.
Okay.
Yeah, so we got that. So now we're gonna say, um, let's think about it. Let's think about it. Okay, so first we have to set the base cases. So go back to line 34. Then we're gonna do memo at n we equal nums at n, and then n minus 1 we equal nums at, yeah, and then on the for loop we're gonna do n minus 1, n minus 2, so we can start at position 3. So we can start position at the third position. No, -1, -1, but then on the end, on the end, -2. Yeah. So now we're starting at 3 instead of 5. We're starting at 3. Yeah or nay?
Yay.
Yeah. Okay.
Yay.
So now we're gonna go. We're gonna click enter. We're gonna say memo at I Okay.
will equal the max,
Exactly. The
the
max.
remainder.
Yes. But for that we need another for loop
Another for loop.
to keep. Yeah. So it's gonna be like a line 40.
Do we need another for
And
loop?
I think so. Yeah. Yeah. So we can do for age in range of I. Is it I? No. I minus one. I minus one. Because then we want to start at 4, right?
Yeah, you know what I
Yeah.
hate? I hate that I'm thinking about it in like reverse, and then thinking of I minus one, and I'm trying to like figure that out. So okay, so since
No,
we're
I
going in
plus 4. I plus 4. I plus 4.
I
No, yeah,
four.
I plus 1. I plus 1. My bad. My bad.
So I have a
Yeah,
question.
cuz
So
yeah.
since we're going in reverse, is index 0 all the way at the right side?
It's on the left side.
So it's still on the left side,
Yeah.
but we're just starting from the back.
Yeah.
So I plus one. Yes. So
Yeah, so we're at 3, right? I is at 3, so we need a 4 all the way
we're do I
till
plus two.
we're I plus 2, which is 3, right? In the our little example we have, right? So we want to start at so we want to get the maximum from
From
I
I
plus
plus
2.
two
I plus
to
2
the end.
I plus to the maximum, which is n plus 1, because we subtract.
See,
Yeah,
look, there's
exactly.
it's in. Okay, anyways, keep going.
Why?
Huh?
What happened, my guy?
It's just like sometimes these trick me up here. The plus
Well, it's
one and stuff like that.
the n plus 1, right? Remember we subtracted the negative 1, right? On line 32. So n on line 32 is adjusted to start at 0, right? 0 all the way to n, right? But in the for loop, it ends 1 before n, right? So we have to give the like, get that extra 1 to end at the right place. I don't know if that makes sense.
Yes.
Yeah, give or
Okay.
take,
So
give or take.
this is exclusive. So
That's
at n
exclusive.
plus one, it's gonna stop at n.
It's gonna stop at n.
This
Yeah,
right here, you're saying the length of nums, which let's say it's 5, it's gonna give us
it's gonna give
zero,
us
1, 2, 3, 4.
4. Yeah,
So you're saying you want 0.
1, 2, 3, 4. But since the for loops are exclusive, we need that 5 to end at 4, right? Because it doesn't end at 5. It doesn't end at 4. It ends at 3. It ends the one before. So we need to give that plus 1,
Why quit?
right?
Okay, I have a question. So
Yeah.
length, let's say it's 5,
Yeah.
right? Let's say there's 5 elements in it.
1, 2, 3, 4, 5. Starting at 1.
Yeah. Doing this, we'll do.
0, 1, 2, 3, 4. So you shift it to 4, so you can do 0, 1, 2, 3, 4 in
But
in
then
the
you want to
other one.
create the array, and you add one
Yeah.
again to make it total
Well,
of
because you
5
need 5.
elements.
Yeah.
So
You need 5
why did
elements.
we just
I
why
don't
do
know.
we
You put it in.
no, you
You
told
were the
me.
one. You
No,
told
no,
me. No, no.
no,
Yes,
no,
yes,
no,
yes. You were
no.
like, let's
No, I don't
create a
want.
variable over here. And I was like, all
Yeah,
right,
but
all right.
I didn't say -1.
Well, yeah, because it has to be minus 1.
Well, that's why I'm
Well,
asking.
it's
Like, why
because
did we do -1? Why can't we just put n? Since we're gonna
and
do n
do
right here, like we just add it
well
again
on
right
line
here.
36, we're gonna do n minus 2. If we didn't have the negative minus 1 on line 32.
Okay.
So it
Yeah.
has its benefits. It has its
Yeah. That's
benefits.
just yeah. I
Yeah.
just sometimes. Anyways, I'm sorry. I'm back.
All good, all good.
So
So that is gonna go from 4 to 5, right? And then we have to keep the maximum. So we have to create a variable on line 30, 40. So we're gonna enter right between the two both for loops, max will equal 0. And then we're just gonna loop max num will equal to the max of
Well, I mean, if we're looping through it, can't we just right? Like, oh no.
yeah
Oh no, max
of nums at h. No, of memo
yes.
because
Because we
memo
stored already.
at
Memo
h
H
all the way
max.
to
No.
max nums. Yep. So
Okay.
that is gonna equal, so now on line 44, 45, we're gonna do nums at position I, because we still have to count for that one, plus the nums plus the max num, and I think that should be it.
What do we return?
We have to return
Oh,
the
return the
maximum
max.
so here we can have another called result or something outside the for loops on like line 38, right, which
Sure.
we can set it to like 0.
Yep.
And then for each memo at I, every time we calculate a new memo, we get the maximum based on the result. For example, res will equal to the max of memo I, comma result, comma res. There we go. Yes, sir. I don't think. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Oh my God, brother.
Dare I run it? Dare I submit?
Submit it, brother. Submit it. Submit it. Submit it. Wait.
Oh, dude! I clicked and I moved out. Hold up.
Submit it.
I don't want
Submit
to
it,
let
brother.
go.
Submit it.
Okay, I let go.
Submit it. Submit it. Submit it.
Okay,
Submit it.
submit it. Okay,
Yeah, submit it. Submit it.
submitting.
Oh,
Just what we wanted, baby. Just what we wanted.
damn, bro. That's your
Let's
fault, brother. That's
go.
your fault. Nah, I'm kidding. I'm kidding. Let's see. Hey, hey, it's okay. It's okay. It's okay.
Because
Use test case.
we don't loop through anything since there's one element. It worked for this one because we started off with 0 and we're returning 0.
yeah.
But if you put 10,
Oh,
it's
that's
not
so
gonna
smart. Yeah. Run it.
it
Yeah.
return 0, man. I mean, yeah.
Wait.
Chihuahuas.
Let's see. Okay, so we just have to create a if statement before we initialize anything. We do if uh if length of nums equals 1, and I think it's before we even create the array, the memo array, and everything. Because right,
If
right there.
n
If n
equals
equals
0,
0, return nums at position 0. Yeah. And check 2 and 3. Check 2 values and 3 values. 2 and 3 values.
I'm disappointed, man.
Check 2 values.
Oh,
Yeah,
good
check
catch,
that.
good
Yeah.
catch. So, I mean, couldn't we just adjust this right here?
Well, it depends, because it depends what's happening with 2 values, because it's creating memo, it's creating at 1, 2, so that's creating 2. Create that. We set those values 10 and 9. Then we set 0. Okay, I see. I see. Okay, I see. I see. I see what's happening. Since we have two values, right? Um, we got two values, 10 and 9. We go into I, right? And I n minus 2, or we can also do that. Yeah. Yeah, you're right. You're
Because
right. We can also
those
do
are our
that.
base cases. So like,
Yeah, those
if
are
we
our base
have
cases.
two of the base cases, just return the
That's
max.
so smart. That's so smart. Yeah, 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 yeah.
Dude, I'm on one today, bro.
Bro,
Man,
you're
I should take naps more often. Maybe the morning. Maybe I'm like I just woke up and stuff. Like, dude, we might need to switch. Oh, maybe I'm not on one. Um, maybe during the break we switch up the schedule. I don't know. We'll see. We'll see what happens. Well, maybe mornings are my thing. I don't know. We'll see.
we'll see, we'll see, we'll see.
What do you think?
All right, run it, brother. Run
Run
it,
it.
run it, run it.
Running it.
Woohoo!
I'm not plugged in, man. I'm not plugged in,
All
bro.
right, let's see what's happening. Don't. All right, let's see, let's see. Mm.
Cheese
Hey,
Fest. What's up,
TCS,
Cheese
welcome,
Fest?
brother. Welcome to the stream, brother. Welcome to the stream. Yeah,
Bro, I'm
remember
not
you
locked
guys.
in.
Hey, brother. Thank you, brother. Thank you for coming back. Wait, why is it returning to? Oh,
Because
set res? No. Set 39, line 39, right? Line 39, that's where declare res is there. Res equals 0. And then on return, instead of returning the maximum, just set res to the max of those two. Like on line 41. No, set
okay,
0.
okay.
Yeah. There we go. Yes, sir.
This
And
is
now,
a house robber. House robber.
yeah, house rubber problem 190, I think.
What are you gonna say?
Go for it. 198. My bad, my bad. Let's go, baby. Let's go.
Classic, yeah. We solved it already, like with recursion, and then
And memo. But
the
right now we're doing
memo.
some a little bit of
We're
dynamic.
trying to do it dynamically. So here's our code previously. But
All right, submit it,
dare I
brother. Submit
submit,
it.
bro? We already messed up 2 times already.
Yeah, submit it,
Can we
bro.
make it 3? Let's make it 3.
Yeah. Sir. Let's go. Let's go.
Hey,
Hey,
good stuff, man.
hey. All right, brother.
That's it. We're calling it.
We're calling it here, bro. I think my stomach is it's fine. It's
It's
grinding for some
12
food.
a.m. It's midnight. We have class
It
at
is midnight.
8:30.
We
We're
have class in
cooked.
8 hours.
And you're gonna eat.
A little
Oh yeah.
bit. Something small. Something light.
All right. Before everyone goes, we like to do an insane level. We haven't done it
We haven't done it in a bit.
today, and that's because we're like locked in. So let's just do that real quick before people go away. All right, Jose, what's your insane level, man?
That was way more than 10 minutes. Hey, what do you mean? They keeping track time track on us, bro?
Yeah.
What? Hey, my insane level, I'm actually pretty good. I'm
Dude,
looking at 5,
out of 5,
5.
5,
Yeah,
5.
because I'm like a little bit of hungry, a little bit of
Okay, a little
hunger in
hungry.
there.
Hunger's playing a
But it's
factor.
5, 5. Yeah, but I'm like a 5. I'm like a 5.
I would say I'm at honestly, you might think I'm lying, but
Yeah.
I'm with you with the 5.
Hey, fair
Yeah.
enough. Fair
Yeah,
enough.
and I think this is good because like usually we would be at like a 9 or whatever. No, like I'm at a 5. I'm
Yeah,
pretty
right.
even out.
Hey, hey, yes,
But
sir. Hey, you did pretty good job, bro. I
hey,
think
I appreciate it, man.
you're doing a lot better with the recursion. You helped me out with the dynamic. You catched on to that pattern. I was
I
like,
appreciate it.
oh
Hey,
damn,
hold
yeah.
up, hold up, hold up. We got 6 concurrent viewers. I need one of y'all.
Hey,
One to
oh
sub.
my God.
We're almost at 150.
One more
And
time, boy.
me and
One
Jose
more
were
time.
talking about it that if you need any help, wingman, anything like that, because remember it's a flex. It's a flex to hit those numbers like the 100, the 200, the
Yeah,
250,
like imagine being the
450.
450th
Imagine being the
subscriber.
450 sub. Like that would be crazy. And then you
Exactly.
flex it to the Huz, you know, and, and you say like,
That
"Yo,
it.
I'm 450. I'm 450. You know,
Come
hardworking
on,
geniuses."
cheese
And
fest.
basically we'll vouch for you. We'll say, "Hey, you're a good
Mm.
person. You know, we remember back in the day they helped us out. Blah 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 blah. All this stuff. So you don't got to. We'll vouch for you."
Who vouch for
And
you?
yeah.
Yeah, for
Anyways, we
sure.
could keep going about how we'll vouch for you or whatever. But anyways, we're one
Hey, come
away
on.
from 450.
I think how many likes we got? We got 3 likes. All right, I refreshed. We got 3 likes.
Three
I
likes, three
was about to
likes.
say,
We'll take
yeah,
three
we
likes. We'll
got three
take three
likes.
likes.
We take the 3 likes. We take the 3 likes.
But anyways, we
So
stream. I don't know if y'all see the pin message. We stream every Wednesday at 10 a.m. We've been streaming for the past 40 weeks. 40 weeks. That's
40
almost,
weeks.
we're 12 weeks away from a year.
12
So
weeks
we've
from a year,
so we've
bro.
never missed. We haven't missed a
That's
week
great.
of LeetCode. And you could verify it, go back to this other streams we had. And also another cool part is you could go to our first stream and see how much we've improved. So it's really cool to look back. But here's what we're doing. We're doing the LeetCode 75. We already done all these up here, and we decided to skip a little bit since we're learning dynamic programming in class right now. So we're gonna, I think next stream, which should be next Wednesday, maybe.
Show
Show the
the,
LeetCode profile. All
come
right.
on. Let's see.
Le-
Let's see. Let's see.
hold on. LeetCode profile. There it is.
Mm.
There it is. What do y'all think?
Look
What
at
do y'all
it.
think?
Look at it. Uh, there's hasn't been like a row where we missed since March. Each column has green dots.
Yeah, and it's actually funny. The first week we actually started or whatever, we're on a different account. So
Yep,
so
yep,
we're
yep, yep.
missing like 1 week, I believe,
Yeah,
um,
yeah.
on our profile right here. But you see that every week, baby. Come on now, lock in,
Log in, people. Log in.
lock in. And you know, since we started streaming every Wednesday, that's how long it's been. So it's been 6. Oh wait, Jose. What is this?
Oh,
What is this? Hold up, boys. Hold up. Wait a minute. I might be
November
lying.
2? November 2?
What happened here?
Let's see. I'm gonna
This
check
from
the account.
October 27th to the 2nd. Yo, hold up.
27 to second. 20. I got you. I got you.
Let's verify this right now. I might be capping. We might have been capping this whole time, Jose.
Wait. Oh, it's because I'm not in my account. Oh, let's see. No, we should be. We should be. We should be.
Oh, I know why. I know why. I know why. It's
Why?
because
Why?
we
Why?
probably didn't solve a problem.
Oh, we
We
probably didn't submit.
we
We did
weren't.
probably. Yeah.
We just didn't submit it. Or no,
What? What?
not that we
What
didn't
was the
submit it. Is
days?
we failed. That we
What were?
kept failing the thing.
What were the days?
Uh,
27.
27 to the
Yeah, I got
November
a
2nd.
live stream on the 30th,
On the
October
30th. Okay.
30th, 2024. Yeah.
It
Hey,
just so happened that we
hey, you
couldn't
almost got us
pass.
there.
We couldn't get the problem solved. I think that's the reason. And same goes
Yeah.
for these 2 weeks. I wonder what problems we were doing. But anyways, all right, that should be
All
it.
right.
We'll be here next Wednesday, and if not, we'll let y'all know in the Discord. Cheese Fest has been locked in. That's good to hear. Cheese Fest, good stuff, man. Or girl, or cat, or dog, whatever works. That's no
Whatever
problem with me.
works.
There's no problem with me.
Yes, sir.
So or cheese ball,
Or cheese fest. You know.
cheese ball, or cheese, shredded cheese, whatever works. But anyway, Jose, any last words, man, before we go?
Oh no, I'm good. Thank you guys for tuning in. We got a great turnout. Thank you for the likes. Thank you for we got 4 likes now. You know. So thank you guys for it. I really appreciate it from the bottom of my heart. Thank you guys for coming in. And with that said, I don't know if you got anything to say, Carlos.
Try to ring the bell sometimes. You could ring the bell. You get notified whenever we stream. But it's every
Yeah,
Wednesday, and
every
sometimes we
Wednesday.
got to do emergency streams, so that's why you have the bell, so you know whenever we do the emergency stream. But
Yeah, also join the Discord. There's where we post some announcements and stuff like that. So pretty cool. There's some people there that help out. They reach out to other people and work out some LeetCode problems. This is a great thing. We only have 100 feet, 100. How many? Only
100
have 100
invites,
seats. Only
100
100
seats,
invites.
limited,
100 seats. Limited,
limited.
limited, limited for 100 people. I think 60 of them are already gone. So hey,
Yep,
get
40
it,
more
get it,
seats. 40.
get
Get
one
them
before
while
they
they're
run out.
hot.
Yes,
You
sir.
know,
Yes,
it's been
sir.
hot. It's been hot.
Yeah. You don't even get close to it because you're gonna burn yourself.
Yep.
That's how that's how hot they are. But with this said, brother, if you got nothing to say, I think we can call it here. So,
All right. Sounds good.
um, yeah. So thank you guys for tuning in. Have a great day, great morning, great afternoon, great evening, whatever it is in your time zone. Just have a great day, and thank you guys. See you guys next week.
See ya.